Hi and welcome to this video on integration by parts. This video is primarily aimed at students revising for their A-level maths and/or further maths exam, as well as students preparing for or partaking in a STEM-based degree. If this is the first video from my collection that you are watching, you may want to take some time to watch my introductory video. This should give you a better idea of how to get the most out of these videos. So what is integration by parts? Integration by parts is similar to how you can differentiate the product of two functions using the product rule. It allows you to integrate the product of two functions. I.e., you can integrate something of the form y equals u of x times v of x. This notation shows that both u and v are functions of x. The formula for integration by parts states that if you have an integral of the form u times dv by dx, and you're integrating with respect to x, then the answer is u times v minus the integral of v times du by dx with respect to x. It is not set what function you should use as u and which function you should use as dv by dx when looking at integrating the product of two functions. However, if one of the two functions would differentiate to something nice and simple, we should pick this as u. So let's take a look at an example. Question 1. We would like to integrate x times e to the power of 3x dx. Here, as x differentiates to something nice, in this case 1, I'm going to let u equal to x. This means that dv by dx must equal e to the power of 3x. From this we know that du by dx equals 1, and then v, the integral of dv by dx, equals 1/3 e to the power of 3x. I would recommend writing out what all four of these values are each time, as it makes it a lot easier to use the formula. So substituting these values into the formula gives us that the integral of x times e to the power of 3x dx is equal to uv, which is x times 1/3 e to the power of 3x, minus the integral of du by dx times v, which is just 1/3 e to the 3x dx, which equals 1/3 times x times e to the 3x minus 1/9 times e to the 3x plus our arbitrary constant c. We can factorise this to give us 1/9 e to the 3x times 3x minus 1 plus c as our final answer. Moving on to our second example, we want to integrate ln x. At first glance, this doesn't appear to be a product, but remember that actually ln x times 1 is just ln x. So here I'm setting u equal to ln x and dv by dx equal to 1. So du by dx is 1 over x, and v is x. We can then put these values into the formula above, so we get that the integral of ln x dx equals u times v, so x times ln x, minus the integral of v times du by dx, which in this case is x times 1 over x, so just 1 dx, which gives us our final answer of x times ln x minus x plus c. On to the third example. We want to integrate x cubed times cos of x squared dx. At first glance, you might think that you should break this up into the product of x cubed times cos of x squared. But instead, I'm actually going to split this up so that u equals x squared and dv by dx equals x times cos of x squared. From this, we know that du by dx equals 2x, and v must equal a half times sine of x squared. Putting this into the formula then gives us that the integral of x cubed times cos of x squared dx equals u times v, so a half x times sine of x squared minus the integral of v times du by dx, so that's just x times sine of x squared dx, which gives us our final answer of a half x times sine of x squared plus a half of cos x squared plus c, as the differential of x squared is 2x, so this x here cancels out. This is our final answer. The next set of examples I will not go through. Instead, this is your opportunity to have a go. After writing up the question, there will be a 5-second countdown before the answer is revealed. Question 1. We would like to integrate e to the power of 6x times sine of e to the 3x. 5, 4, 3, 2, 1. The solution to this integral is minus 1/3 times e to the power of 3x times cos of e to the 3x plus 1/3 times sine of e to the 3x plus c. Moving on to our second example. This actually requires integration by parts to be applied more than once. we would like to integrate sine of 3x times cos of 5x. 5, 4, 3, 2, 1. The solution to this integral is 5/16 times sine of 3x times sine of 5x plus 3/16 times cos of 3x times cos of 5x plus c. Thank you for watching this video.